What is localization drift in robotics? Imagine a robot navigating through a busy warehouse or a complex city street. It needs to know exactly where it is at all times. But sometimes, its sense of location starts to drift away from reality, and that's what we call localization drift. It's like when you lose your way in a new place because your map isn't perfectly accurate. Localization drift happens because robots relying on sensors to figure out where they are. These sensors include wheel encoders, inertial measurement units, cameras, and laser scanners. Each of these tools helps the robot estimate its position and orientation. But none are perfect. Small errors in measurements can add up over time, making the robot believe it is somewhere it is not. Wheel encoders measure how much the wheels turn, but if the wheels slip or the terrain is uneven, the measurements become inaccurate. Inertial measurement units, which track movement and rotation, can also drift because of biases and noise in their sensors. Visual sensors like cameras and laser scanners can lose track of features in the environment, especially if the surroundings change or are featureless. This buildup of errors causes the robot's internal map of its location to slowly become less reliable. In autonomous systems, this can lead to serious problems. The robot might think it is in a different spot than it really is, which could cause it to bump into obstacles or take wrong turns. That's why managing localization drift is so important. To fix this, robots often combine data from multiple sensors in a process called sensor fusion. They use algorithms like simultaneous localization and mapping, which helps the robot build a map while keeping track of its position. For example, laser scanners can help correct errors from visual sensors by providing accurate distance measurements. When a robot recognizes a familiar landmark or previously visited place, it can adjust its position estimate. This process is called loop closure. In autonomous navigation, controlling drift is essential for safe and precise movement. Robots use techniques like map-based corrections, sensor fusion, and loop closure detection to stay on course. These methods help keep the position estimate accurate over long distances and time. In summary, localization drift is the gradual error that builds up in a robot's sense of where it is. It happens because sensors are not perfect and environmental factors can interfere. Managing this drift with smart algorithms and multiple sensors makes autonomous systems more reliable and capable of navigating complex environments confidently.